Now we are going to look at how we can combine powers to make them simpler. Some of these things, like this nasty one, look pretty confusing. We've got an exponent multiplied by another one, multiplied by another one. But there are some rules that we can use if the bottom number, the base, is the same, to simplify it, to make it simpler. Look at this one. The rule says that if we've got the bottom numbers the same, and they're multiplied together, these two exponents, then we need to add these top numbers, add the powers together. So this one, x squared times x cubed, I would have to add 2 plus 3 makes 5. That's not so bad. You can think of it as this is x times x times x times x times x. That's 5 x's all multiplied together. So it's x to the power of 5. Cool. We can do something similar here, but we won't be able to simplify it as much. This is y to the power of 5 plus a. I can add these exponents together because the bases are the same, and these two exponents are multiplied. So I can add these powers together, 5 plus a. We could do something similar here, but it's trickier for 2 reasons. Number 1, there are 3 numbers. That's all right, we can add 3 things. And number 2, there's no power here. The rule only works if each of these things has an exponent. It has power. So we need to write q as q to the power of 1. That's the same as q, isn't it? So now that we've written it this way, we can see that it's q to the power of 5 plus 1 take 2. I add these 3 numbers together. It happens that here I'm adding a negative number, so I just subtract. 5 plus 1 take 2. 5 plus 1 is 6, and 6 take 2 is 4. So it's q to the power of 4. All right, but what if we had 2 exponents divided? Yeah, so an exponent divided by another another exponent. Well, what we would do is we'd get these powers at the top and we would have to subtract them. The top take the bottom. So this one, we can use it because the base is the same. So the answer would be j to the power of 10 take 4. That's what this rule is saying. It's the top power take the bottom one. J to the power of 10 take 4. And we can simplify this a little bit because 10 take 4 is 6. So this is j to the power of 6. And we're done. We've simplified it as much as we can. And this is quite a bit simpler than the first part, than the question. This one will work exactly the same way. The base number is the same. I subtract the exponents, the powers. Same thing, I suppose. So this will be g to the power of 4 take 6. If you have a fraction of exponents, then you subtract these powers. Now on the next line, I can copy down equals g 4 take 6, or 4 take 6 is negative 2. You can imagine a number line. I have 4, I subtract 6, then I'll go all the way past 0 into negative. And that's simplified. The last one we see here is if you have an exponent and you raise it to another power. This thing here is going to get very, very big. This means get the number 2 and cube it. 2 times 2 times 2 happens to be 8. So this thing inside the brackets is 8. And then get that number and multiply it by itself 4 times. 8 times 8 times 8 times 8. The answer is going to be absolutely massive. But we can write it, simplify it, pretty simple I think, if we use this rule. If you have an exponent on the outside of the bracket and an exponent on the inside of the bracket, there's just one exponent here, you can multiply these two things together. This is 2 to the power of 3 times 4. And on the next line, I can simplify because I know what 3 times 4 is. So I can replace that with the answer to 3 times 4, which is 12. Everything else, the equals, the 2, I just copied down. 2 to the power of 12. Okay, last question on this page. Very, very similar. I've got an exponent on the outside of the bracket, exponent on the inside of the bracket. So this will be x to the power of 4 times 2. I multiply those things together. which is x to the power of 8. Beautiful. And that's how you do the first 3 questions of exercise 2B.1 on page 30. Give it a crack and see how you go if you like some practice with this. All right. Good luck, everyone. Bye.